So problem number 24 from today's sprint round reads, let A, B, C, D be an ordered quadruple of non-negative integers such that 0 is less than or equal to A, is less than B, is less than C, is less than D, is less than or equal to 7. What is the sum of all distinct possible values of 2 to the power of A plus 2 to the power of B plus 2 to the power of C plus 2 to the power of D? First of all, let's figure out how many numbers in particular that we're talking about. Since A, B, C, and D have to be 4 unique numbers, and all in the range of 0 to 7 inclusive, then we know that we can just pick any set of 4 numbers from the interval from 0 to 7 inclusive and get a single distinct value of 2 to the power of A plus 2 to the power of B plus 2 to the power of C plus 2 to the power of D. Because no matter what set we pick out, as long as we order it, it'll be exactly one possibility for the values of A, B, C, and D. So picking 4 from this interval, there are 8 numbers total in this interval, and 8 choose 4. Y'all should know it, but it's 8 times 7 times 6 times 5 and divided by 4 times 3 times 2. 3 times 2 is 6. We can cancel out that 6. And we can cancel out the factor of 4 and 8 to get 2 times 7 times 5. 7 times 5 is 35. 2 times 35 is 70. So we have 70 distinct possible values of 2 to the power of A plus 2 to the power of B plus 2 to the power of C plus 2 to the power of D. But that's a lot of calculation, and we want to find a slick way to figure out exactly what the sum of them all are. We don't have to compute all of them separately. So let's think about it using the power of bases. One thing that you should see if you think about it is that any random A, B, C, D set, its sum when it's put into these exponent values is going to be a unique 8-digit number when put into base 2. So for a random example, 2 to the power of 1 plus 2 to the power of 3 plus 2 to the power of 4 plus 2 to the power of 7, that's going to be, well, this digit is going to be 0 because this is 2 to the power of 0. 2 to the power of 1 is present, so 1 will go here. We don't have 2 to the power of 2, so 0, and so on. 1, 1, 1, 0, 0, 1. That's a unique 8-digit number in base 2. And not only that, but you should see that 4 of its digits are 1s and 4 of its digits are 0s. If we were to change the position of any of these 1s and 0s while keeping the same number of 1s and 0s, we would have a distinct number that would also satisfy this expression. So for instance, let's say we reversed the pattern of 1s and 0s. So in every space that has a 1, we give it a 0, and for every space that has a 0, we give it a 1. This is a new number in base 2. If we were to turn this into a sum of powers of 2, then we would get its own unique set, which would satisfy this expression. And these will both be in the 70 values that we talked about recently. In addition, if we were to add these two numbers, we would get a number that's just 8 1s in a row in base 2. And converting this number to base 10 should be fairly simple. We know that this is 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2, so on up to 2 to the power of 7. The next number up from that will be 2 to the power of 8, or 256. So this number, when converted to base 10, is going to be 255 base 10. Going back to this, we should also see that since for every number in our set of 70 possible values, we can generate its matching twin, like so, as we did here. And that set of two numbers will add up to 1111111 base 2, or 255 base 10. We have half of 70, so 35 of those pairs that will add up to 255 base 10. So our final answer is going to be 35 times 255, the universal sum, or 8,925 once we compute it, which is answer B on our test. And we're done. Thank you for listening.
Hey, this is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.